Class 7. Algebraic expressions. In Class 6, we have learnt about simple algebraic expressions like x plus 4, y minus 3, 2x plus 3, 2y minus 7 and so on. A symbol having a fixed numerical value is called a constant, and a symbol which can take various numerical values is called a variable. In this chapter, we shall study algebraic expressions involving one or two variables. We shall also study about their addition and subtraction. Algebraic expression, a combination of constants and variables connected by some or all of the four fundamental operations. Addition, subtraction, multiplication and division is called an algebraic expression. Examples: 2x squared y minus 5x plus 6, 2xy minus 8, y squared z plus yz plus 7 are a few examples of algebraic expression. Terms. The different parts of an algebraic expression separated by the sign plus or minus are called the terms of an expression. Examples: 4 minus 5x plus 2x squared y is an algebraic expression having three terms, namely 4 minus 5x and 2x squared y. 2x cubed minus 5x is an algebraic expression having 2x cubed and minus 5x as its terms. Factors of a term. The algebraic expression 5x squared minus 2xy consists of two terms, 5x squared and minus 2xy. The term 5x squared is a product of 5x and x. We say that 5x and x are the factors of the term 5x squared. Similarly, the term minus 2xy is a product of the factors minus 2x and y. Therefore, a term is a product of its factors. We can also represent the terms and factors of the terms of an expression by a tree diagram. Let us draw a tree diagram for the expression 2x squared y minus 7. Expression 2x squared y minus 7. Terms 2x squared y minus 7. Factors 2x, x, y. Example: represent 5x squared minus 7xy by a tree diagram indicating terms and factors. Solution. Given expression is 5x squared minus 7xy. Expression 5x squared minus 7xy. Terms 5x squared minus 7xy. Factors 5xx minus 7xy. Coefficients. The coefficient of a term of an algebraic expression may be the numerical or variable factor or both. Example: in the term 5x, the numerical coefficient of x is 5 and variable coefficient of 5 is x. When the coefficient of a term is plus 1, it is usually omitted. Example: in x squared y squared plus 6, the coefficient of x squared y squared is 1. The coefficient minus 1 is indicated only by the negative sign. Example: minus 1x squared is written as minus x squared. Like and unlike terms. The terms having the same variable factors are called similar or like terms. Like terms may differ in their numerical coefficients. Example: in the expression 3xy minus 4x plus 5yx plus 7, the factors of 3xy are 3x and y. The factors of 5yx are 5y and x. Thus, their algebraic factors variable are same. Therefore, 3xy and 5yx are like terms. The terms not having same variable factors are called unlike terms. Example: in the expression 3xy minus 4x plus 5yx plus 7, 3xy and minus 4x have different algebraic factors. Similarly, 5yx and 7 have different algebraic factors. Hence, 3xy and minus 4x are unlike terms. 5yx and 7 are also unlike terms. Types of algebraic expressions. Monomial, an expression which contains only one term, is known as a monomial. Thus, x, 3x, minus 3xy, 4x square y, abc, minus 9 are all monomials. Binomial, an expression which contains two terms, is called a binomial. Thus, x minus 5, 2x plus 3y, x squared minus 7, 4x squared minus y are all binomials. Trinomial, an expression which contains three terms, is called a trinomial. Thus, x cubed minus y cubed plus 2z cubed, x plus y minus 5, xyz plus 6 plus x squared are all trinomials. Quadrinomial, an expression which contains four terms, is called a quadrinomial. Thus, 2x squared plus y squared minus z squared plus xyz, a cubed plus 3a squared b plus 3ab squared plus b cubed, x plus y plus z minus 6 are all quadrinomials. Polynomial, an expression which contains one or more terms, is known as polynomial. So, binomials, trinomials, and quadrinomials are all polynomials, since they have either two or more terms in all. In a polynomial, a variable cannot appear in the denominator. Example, 3x plus 5, 7x squared minus 6x plus 1 are polynomials. 2x minus 3 upon x minus 7, 2x cubed plus 5 upon x squared minus 7 are not polynomials. Example 1. Write down the coefficient of x in minus 2xy. Solution. X in minus 2xy minus 2xy is equal to minus 2y into x. Hence, the coefficient of x in minus 2xy is minus 2y. X in minus xyz. Solution. X in minus xyz minus xyz is equal to minus yz into x. Hence, the coefficient of x in minus xyz is minus yz. Example 2. Write the numerical coefficient of xy. Solution. xy is equal to 1 into xy. Therefore, the numerical coefficient of xy is 1. Minus 5xy squared z. Solution. Minus 5xy squared z minus 5xy squared z is equal to minus 5 into xy squared z. Therefore, the numerical coefficient of minus 5xy squared z is minus 5. Example 3. Write the constant term of the following polynomials. Minus 2x squared minus 9. Solution. Minus 2x squared minus 9. The constant term in minus 2x squared minus 9 is minus 9. A squared plus ab minus 5 upon 2. Solution. A squared plus ab minus 5 upon 2. The constant term in a squared plus ab minus 5 upon 2 is minus 5 upon 2. Degree of a polynomial. The highest power of the variable in a polynomial is called its degree. If a polynomial consists of more than one variable, then the sum of the powers of variables in its different terms determine its degree. The degree of the polynomial in such case is the highest sum of the powers. Case 1. Polynomial with only one variable, that is 7x squared plus 4x plus 6. This is a polynomial in one variable, that is x, and the highest power of x is 2. Hence, the degree of the polynomial is 2. Case 2. Polynomial with more than one variable, that is 8x squared y plus 3xy plus 4x cubed y squared. Here, degree of term 8x squared y is equal to 2 plus 1, which is equal to 3. Degree of term 3xy is equal to 1 plus 1, which is equal to 2. And degree of term 4x cubed y squared is equal to 3 plus 2, which is equal to 5. As the highest degree is 5, hence 5 becomes the degree of the polynomial. Types of polynomials. Linear polynomial. A polynomial of degree 1 is called a linear polynomial. Examples: 2x plus 3 minus 5x, 3 upon 2y plus 7. Quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. Examples: x squared plus 5x minus 6, 2x squared minus 7, xy plus 2x minus 6. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. Examples: x squared y plus 2xy minus 5, x cubed minus 5x squared plus 6, 6x cubed minus 7. Example 1. Write the degree of the following polynomials: minus x squared plus 5x. Solution. In polynomial minus x squared plus 5x, highest power is 2, hence its degree is 2. 4x squared y plus 5xy minus 4x. In polynomial 4x squared y plus 5xy minus 4x, there are two variables, x and y. Degree of the term 4x squared y is equal to 2 plus 1, which is equal to 3. Degree of the term 5xy is equal to 1 plus 1, which is equal to 2. Degree of the term minus 4x is equal to 1. Since highest degree is 3, hence the polynomial is of degree 3. Example 2. Name the expressions on the basis of number of terms and degree of the polynomial. 6x squared plus 2x minus 5. Solution. The algebraic expression 6x squared plus 2x minus 5 has three terms: 6x squared, 2x, and minus 5. Therefore, it is a trinomial. The highest power is of the term 6x squared, that is 2. Hence, it is quadratic polynomial. Finding the value of an algebraic expression. We know that an algebraic expression contains one or more terms. Each term further contains one or more variables and some numerical coefficients. If the values of all literal variables are known in a given expression, then, on replacing these variables by their numerical values, we can obtain an arithmetic expression which can be evaluated. The process of replacing the variables by their numerical values is called substitution. Example: if x is equal to 1, y is equal to 3, and z is equal to minus 1, find the value of 5x plus 3y minus xyz. Solution. We have x is equal to 1, y is equal to 3, and z is equal to minus 1. 5x plus 3y minus xyz is equal to 5 into 1 plus 3 into 3 minus 1 into 3 minus 1, which is equal to 5 plus 9 plus 3, which is equal to 17. 4x squared y plus 3xz minus 10. 4x squared y plus 3xz minus 10 is equal to 4 into 1 squared into 3 plus 3 into 1 minus 1 minus 10, which is equal to 12 minus 3 minus 10, which is equal to 12 minus 3 plus 10, which is equal to 12 minus 13, which is equal to minus 1. Addition of algebraic expressions. Consider the following example. Anita had 7 apples, whereas Anil had 6 apples. To find total number of apples, we find the sum of the apples that Anita and Anil have together. 7 apples plus 6 apples is equal to 7 plus 6 apples, which is equal to 13 apples. Similarly, 9 oranges plus 8 oranges is equal to 9 plus 8 oranges, which is equal to 17 oranges. We know that an algebraic expression consists of like and unlike terms. The operation of addition and subtraction on algebraic expressions means adding or subtracting like terms. Example, add 5x and 9x. 5x plus 9x is equal to, within brackets, 5 plus 9x, which is equal to 14x, by distributive law. Similarly, sum of 7x plus 8x and minus 3x. 7x plus 8x minus 3x is equal to, within brackets, 7 plus 8x minus 3x, which is equal to 15x minus 3x, which is equal to, within brackets, 15 minus 3x, which is equal to 12x. Thus we see that sum or difference of several like terms is another like term, whose coefficient is the sum or difference of the coefficients of those like terms. Let us take some more examples. Addition of positive like terms. Example, add 7ab, 8ab and 4ab. Solution, 7ab plus 8ab plus 4ab is equal to, within brackets, 7 plus 8 plus 4ab, by distributive law, which is equal to 19ab. Alternative method. The sum of numerical coefficients of given like terms is equal to 7 plus 8 plus 4, which is equal to 19. Since the sum of the given like terms is another like term, whose numerical coefficient is 19. Hence, 7ab plus 8ab plus 4ab is equal to 19ab. Addition of negative like terms. Example, add minus 4x squared y squared minus 6x squared y squared minus x squared y squared and minus 5x squared y squared. Solution. Numerical coefficients are, without negative sign, 4, 6, 1, 5. Sum of 4, 6, 1 and 5 is equal to 16. Hence, minus 4x squared y squared minus 6x squared y squared minus x squared y squared minus 5x squared y squared is equal to minus 16x squared y squared.
Addition of positive and negative like terms. Example, add 4x square y, 6x square y minus 2x square y and minus 3x square y. Solution, 4x square y plus 6x square y minus 2x square y minus 3x square y is equal to 4 plus 6 minus 2 minus 3 x square y, which is equal to 10 minus 5 x square y, which is finally equal to 5x square y.
Addition of algebraic expressions with while adding algebraic expressions having like and unlike terms, we collect different groups of like terms and find the sum. It can be done by two ways. Horizontal method. In this method, expressions are written in a row, horizontal line. Then the terms are arranged in group of like terms and then added. Column method. In this method, each expression is written in a separate column, such that their like terms are arranged one below the other in a column. Then terms are added column-wise. Example, add the expressions 2x squared plus 4y squared, x squared plus 5y squared, and 3x squared plus 2y squared. Solution, 2x squared plus 4y squared plus x squared plus 5y squared plus 3x squared plus 2y squared is equal to 2x squared plus x squared plus 3x squared plus 4y squared plus 5y squared plus 2y squared, collecting like terms together, which is equal to 6x squared plus 11y squared. Subtraction of algebraic expressions. To subtract an algebraic expression from another, we change the sign plus to minus or minus to plus of each term of the expression to be subtracted and then add the terms. The difference of two like terms is a like term whose coefficient is the difference of the numerical coefficients of those like terms. Examples: 7a squared minus 3a squared is equal to, within brackets, 7 minus 3a squared, which is equal to 4a squared. 5x squared minus 9x squared is equal to, within brackets, 5 minus 9x squared, which is equal to minus 4x squared. Let us take some more examples. Example: subtract 30xy from 12xy. Solution: 12xy minus 30xy is equal to 12 minus 30xy by distributive law, which is equal to minus 18xy. Alternative method: 12xy plus minus 30xy is equal to minus 18xy. Example: how much does minus 2a squared plus 6b plus 9 exceed 4a squared minus 2b plus 7? Solution: required expression is equal to minus 2a squared plus 6b plus 9 minus 4a squared minus 2b plus 7, which is equal to minus 2a squared plus 6b plus 9 minus 4a squared plus 2b minus 7, which is equal to minus 2a squared minus 4a squared plus 6b plus 2b plus 9 minus 7, collecting like terms together, which is equal to minus 6a squared plus 8b plus